Hey, this is my second video as I've recorded the first one and my mic was mute. That was kind of a bummer, but hey, here we go again. So, what's a direction field? Okay, direction field and how we use it. Let's say we have a first order equation that we can, first order differential equation we can solve. Uh, well, we use differential direction field to probably the approximate the solution, or you could just say to just to find the derivative of the equation. Okay, now we move on to critical solution and how we find it. Well, the critical solution is just setting y prime to 0. We already know what y prime is, at least for this equation. It's y times y minus 1 times y minus 3. Okay, we set that to 0 and we get the 0 solutions, these solutions. And that's how this is just a graph of this equation right here. It's really kind of bad, but I tried my best. But also I did this on Desmos if you wanted to see. It's actually more clear. Here, let me show you. As you can see here, that's how it's actually supposed to look. Nice and neat. See, the critical points are 0, 1, and 3. Now we go back to the equation. Okay, that's how we just draw it. Now we could also see now, you need to check for stability. And what my best understanding of stability was, is kind of, it looks at a number line of the critical solutions and it sees if one is convergent or divergent. That's how it would affect on the direction field. See, that's our nice equation again. You see, I drew a number line to choose points between the critical solutions that we already have. So between 0, 1, and 3, I just choose points between them to check if after or before the critical solutions are positive or negative. And I'll tell you why would that matter. See, before 0, we chose -1. After 0, 0.5. Between 0 and 1, it's just 0.5. Between 1 and 3, we chose 2. And after 3 to infinity, we chose 4, the closest number. I did the calculation to find out. I would just take these numbers, plug them into the equation, and see what my result would be, if it's a negative or a positive. And I did the calculations right here. Now you could look at the solutions right here. For if I plug in -1, I would get -8. So that's why I put a negative here between negative infinity to 0. You get, if you plug in 0.5, you get 0.625. That's why I put between 0 and 1. It's just a positive. That range is positive. If I plug in 2 to the equation, I will get -2, as you can see here. And that just tells me between 1 and 3 is just negative. And 4, so on, I get 12. And it tells me between 3 to infinity is positive. Now, what negative and positive mean, it says it helps me draw the arrows. And what the arrows mean, it tells me if the direction is moving away from the critical solution or coming toward it. So if it's moving away from it, if it's divergent, I'd say that's unstable. But if it's going toward it, that's stable. That's as far as definition, I think, goes. As you can see here, it's moving away from 0 and it's moving away from 3. But it's going all toward 1. That could tell me that 0 and 3 are unstable, but 1 is stable. Now we go to the graph under it. That's my direction field graph. You see, I drew it as 1, it just goes to, it's just like the arrows here. They just go into 1. And 3, the arrows go away from 3 and 0. So that's what I did. It just goes away from them. And it just tells you here, it just tells you how it's divergent. You can see here, from 3 is it's just gonna diverge from it. But in 1 it's just converging toward it. And 0 is reflecting 3 is just diverging away from it. So that's what the t goes to infinity diverging from 3. That's how it is from here. And if t goes to negative infinity, which is down, is divergent from 0. But if t goes to 1, it's just going to converge. I also drew a graph here to better understand. Let me take these real quick. Just pretend you never saw these. Well, let's see the solution. That's the same as my graph. See, at 3, it's moving away from it. At 1 is converging toward it, and at 0 is moving away from it. Let's see the first solution. See, it goes through 3 because it's a critical point. It's a 0. It goes through 3 and they just diverge. That's just to prove that my how this works. See, it goes through 3 and it just diverge. I go back here. I look at C. See? Oh, I'm moving away from it. Sorry. At C, it's divergent too. Look, it goes through 0 and it diverges through away from 0. That's just to show how 3 and 0 are unstable. But at B, look, this B solution, it went through 0, but it's also convergent to 1. So 1 is pulling it in. That's why 1 would be convergent and the others would be divergent. I did a D solution just to confirm that 1 would be also convergent, even if it came from the other side. So that's all there, just to prove that how efficient this method is. And that's it.